Summarize our module 8. So we talk about the Newton's second law. We know that the force is directly proportional to the acceleration. To get rid of this proportionality, we equate it with a constant k to the acceleration. And by experiment, they notice that the constant k in this equation is just the mass of the particle. So it only says that the bigger the mass, it means that the particle resists to the change of velocity, which is the inertia. So M provides a quantitative measure of the resistance of the particle to a change in its velocity, which is the inertia. So our equation in the Newton's second law, for any unbalanced force, the direction of the unbalanced force, F, is just equal to the mass times the acceleration. So the direction of the unbalanced force is equal to the direction, is the same to the direction of the acceleration. Now the particle does not only moves into the plane, but in real life, it moves in 3D plane. We call that the rectangular coordinates. So as you can see in this coordinate system, we have the x-axis, the y-axis, and then the z-axis. So ato nang gibutangan og tulo ka coordinates. So if this is the particle, it's the distance along x from this, from the origin O, that is measured in x distance, and then towards the y, we call that the y distance, and paingon diri sa z is the z distance. So the force F has three components: the force along x, force along y, force along z. So kung naday tulo components si forces, napoy tulo ka components sa acceleration along x, acceleration along y, acceleration along z. Since the acceleration is related with velocity, they have a relationship. Therefore, we can also say that the velocity, velocity along x, along y, and along z. So the forces can be written in vector notation. We have here the summation of forces along x is equal I hat plus summation of forces y j hat plus summation of forces z k hat is just equal to the mass times the quantity of the acceleration along x I hat plus acceleration along y j hat, acceleration along z k hat. So kung ato siyang tagsan, we have summation of forces along x is equal to mass times the acceleration along x. Summation of forces along y is just equal to mass times acceleration along y. Summation of forces along z is just equal to mass times acceleration along z. Again, I hat, j hat, and k hat are just unit vectors. They do not have any numerical values, but only shows us the specific direction of for this one, the acceleration or the force. So let's say for this sample, we have an f of x, we have a f of x is equal to 10 Newton, and then f of y is equal to 15 Newton, and f of z is equal to 5 Newton. To write it in vector notation, nga di ta malibog, we cannot only write 10, 15, and 5. So in the vector notation, we write as 10 I hat plus 15 j hat plus 5 k hat. So it means there is a force along the x, 15 along the y, and 5 along the z.